Our last example that we did was already in two binomials. Let's look and see what happens when we start with an equation that's in quadratic or that's not factored already. So for instance, x squared plus 6x plus 8 equals 0. Right now, if I were to go to solve this, I have a problem where I have x, only one variable, but I have x squared and 6x. This is going to make it complicated for us. But what we found with the zero product property is that if we could just write this as a product of two binomials, then we could solve it. So let's do that. When I do not have a number in front of x squared, I know that I can look for two numbers whose product is 8 and whose sum is 6 as the end of my binomials. Now, if I had a number out here in front, I would need to use another method, maybe the box and diamond method, if you liked that. I know that there are a couple pairs of numbers whose product is 8, for instance, 1 and 8, but the sum of 1 and 8 would not work. 2 and 4, and 2 plus 4 is 6. And so that is our golden pair for this problem, equals 0. Now this looks a lot like our first example. The product of two things equals 0. Well, then one or the other of those two factors must be equal to 0. That means that x plus 2 must equal 0, or x plus 4 must equal 0. And I can solve both of these equations now. I subtract 2 from both sides. X equals negative 2. And the other, I subtract 4 from both sides, and x equals negative 4. Now I could again plug both of those in and check those problems in my original. You do not always have to do the check, but I would encourage you, at least in these first couple examples, to just try it out and make sure you're on the right track. X squared plus 6x plus 8. When I plug in negative 2, remember to put those parentheses around it. That's going to be really important in your calculator. Negative 2 times itself is positive 4. 6 times negative 2 is negative 12, plus 8 equals 0. 4 plus negative 12 is negative 8 plus 8, and that is 0 equals 0. That checks out. Our other solution was negative 4, so I also plug in negative 4 squared plus 6 times negative 4 plus 8 equals 0. Remember, we're checking to see that that's truly equal. Negative 4 squared is positive 16. 6 times negative 4 is negative 24, plus 8 equals 0. I add the first two, negative 8 plus 8 equals 0, and I end with 0 equals 0. And again, that checks out, which means that these are our two solutions to the equation x squared plus 6x plus 8. I could double check that by graphing it on my graphing calculator. And again, to show that how to graph and solve on your graphing calculator, you can check out that activity lab on page 571. Can talk you through how do we solve this on our graphing calculator. I would encourage you to pause the video right now, try a quick check 2 at this time. Alrighty, once you've tried that, our answer here for quick check 2, our two solutions are x equals 12 and x equals negative 4. Now, I'd like to also take a look at example 3. We're still on page 573. Example 3 gives us an example when we don't have an equation set equal to 0. So for instance, our example 3 is 2x squared minus 5x equals 88. Now the thing about the zero product property is that you must be equal to 0. That's why the word 0 is in the answer, or is in the name. And so right now, we do not have an equation set equal to 0, but we can do something about that. If I want my right-hand side of the equation to be equal to 0, I would simply need to subtract 88 from both sides. Well, subtracting 88 from 2x squared or minus 5x, those are not like terms. So when I subtract 88, it just becomes minus 88 equals 88 minus 88 is 0. Now I see I have a quadratic equation that I can factor and solve. Just a quick refresher on this. When we solve something that has a number out here in front, we use our diamond box method. In the top of the diamond, I put the product of 2 and negative 88, which is negative 176. And in the denominator, I'm looking for a sum of negative 5. The pair of numbers that makes this true is we list some factors of 176. We see that 16 and 11, for that to have a sum of negative 5, we would need the numbers negative 16 and positive 11. You may have to list some factors of 176. At this point, we then use the box, and we put all of our different pieces from that equation in our box. I have 2x squared that goes in the top left corner. Negative 88 goes in the bottom right corner. And then I've split this into negative 16x and 11x. And then I use this box to factor. One row at a time. In the top row, I have x in common. In the second row, I have 8 in common. I'm going to wait to put a minus or plus once I've decided what I need. In the first column, I have 2x in common. And in the second column, I have 11 in common. Now I know that my product is going to be negative, so one of these is plus and one is minus. In this case, the second row has minus in common. So I'm going to say that's going to be x minus 8 and 2x plus 11. Now I can rewrite this as 2x plus 11 and x minus 8. Notice that work was to factor that trinomial equals 0. And now I apply what we just did. I said that with the zero product property, one of these two factors must be equal to 0. Either 2x plus 11 equals 0, or x minus 8 equals 0. Slide this down. To solve for x, I first undo addition. 2x equals negative 11. And finally, I divide both sides by 2. X equals, you could leave that as a fraction, negative 11 halves, or I could write that as the decimal, negative 5.5. And the second, when I solve the right-hand side, or the x minus 8 equals 0, I add 8 to both sides. X equals positive 8. And so again, I have two solutions, x equals negative 5.5 and x equals 8. I can check those back in the very original equation, but we used this zero product property by first solving for 0. Again, this is a good opportunity. Try quick check 3. This is example 3. And when you finish solving that, you would get x equals 6 or x equals 6. But since that's actually the same solution twice, we just have one solution, x equals 6. Now think back to last week when we had only one root or solution. That means that it is a point on the x-axis, and in fact, that's going to be our vertex point. When there's only one point on the x-axis, it is the very bottom or very top of that parabola. Alrighty, one more video here applying this solving method, and then we can get started some practice.